Okay, we're going to get started. I want to welcome everyone to the annual public workshop for the San Onofre Nuclear Generating Station's Artificial Reef Mitigation Project. SONGS is the acronym for San Onofre Nuclear Generating Station, for those of you. Okay, and so the artificial reef is, my name is Dan Reed, by the way. I'm a research biologist at UC Santa Barbara, and I'm one of the principal investigators for the SONGS Marine Mitigation Monitoring Program. And the artificial reef is one component of a comprehensive mitigation program designed to offset the adverse effects of the San Onofre Nuclear Generating Station to living marine sources in the coastal region of SONGS. And the other major component of this mitigation project is a wetland restoration project, and that is being done at San Dieguito Lagoon. There will be a separate public workshop for the wetland project that will be held next month, May 3rd in Del Mar, and information on that workshop can be found at our website right here. So if you go to the homepage of the website, there should be shortly soon a flyer on that workshop. Well, public workshops for both projects are held annually, and the intent of the workshops is to really review the progress of the mitigation projects and meeting their goals, to identify potential problems or hurdles that are hindering them from meeting their goals, and tend to discuss and develop solutions to remedy those problems. The workshops are also intended to be a forum for discussion that includes not only the scientists that have been collecting the data, but also the California Coastal Commission is the lead agency on this project. Other agencies that are interested in the project, the Southern California Edison, and the general public. And so we have members from the Coastal Commission here today. We have members from Southern California Edison, as well as the scientists that have been collecting the data. As you can see from the agenda, there's a period set aside for questions and comments right after the second talk, when we'll be talking about the performance results, and then at the end of the presentations as well. And we will be here to answer all your questions. So yeah, we'll make sure that any questions that come up that we address. And so participants joining the workshop remotely via Zoom will have the opportunity to ask questions either through the chat window or by using the raise hand button if you want to ask your question in person. And both of these features can be found in your Zoom toolbar. Your questions, if you ask them online, will be placed in an online queue, and then they will, in the order that we receive them. Remote participants will have their microphones and videos turned off. And then if you ask your question with the raised hand function, the webinar moderator will turn on your video and microphone. You can ask your question. And after the question's been answered, you'll be muted again. If you have another question, you just raise your hand and you get put back into the queue. And so I'm going to start off the workshop and provide with an introduction, a general overview of the project. It'll be followed by a presentation from Kat Beheshti on results of the monitoring. And then the last presentation will be from Rachel Smith on plans for reducing the monitoring in the future. And so with that in mind, it's important to know something about the SONGS seawater cooling system to understand what the mitigation project is all about. And SONGS, when it was fully operational, the nuclear reactors were cooled by a single pass seawater system. There's two-unit mitigation units, those units have seawater intake systems that consist of large pipes that were 18 feet in diameter, shown in that top right-hand photograph. Those intake pipes were located in about 30 feet of water offshore of the power plant. When it was fully operational, the power plant would bring in something on the order of 2 billion gallons of water a day, which equates to a volume equivalent to about a square mile, 12 feet deep. So that water would go into the power plant. It would get heated up to about 19 degrees above, and then it would get discharged back out into the ocean through these two long diffuser lines. One diffuser line for discharge line for each unit. And at the end of the last 2,500 feet of those discharge lines, there were 63 diffuser ports. And those diffuser ports served to dissipate that hot water as it entered back into the ocean. Okay. So, mitigation. Is there a way to get rid of that on the screen? Maybe not. But anyways, the reef mitigation is linked to the adverse effects of the cooling water discharge, not the intakes, but the discharge, okay? And so the California Coastal Commission convened a group called the Marine Review Committee in the early 1970s that was charged with assessing what the impacts of the power plant were to the marine environment. And the results from those studies that were conducted by the Marine Review Committee, they determined that a turbidity plume associated with the diffusers was the cause for a substantial reduction in the size of the kelp cores. And this photograph on the right there shows, you can see the turbid plume, you can see where the diffusers are, and you can see where the kelp cores was. And so, thank you. That's what the impacts were caused by. It was a reduction in the light actually caused by this turbidity plume that led to a decrease in the birth rates of kelp, not the death rate so much. And that led to this decline in the kelp forest, right? And so, and now I have no, I can't advance the slide now. Is there a problem with that? Apologies here. Okay, so now I can advance the slide. Okay, so the California Coastal Act requires that there be mitigation for marine impacts. And the California Coastal Commission is the agency that's responsible for implementing the Coastal Act. And what the Coastal Commission then decided was to mitigate the impacts of songs to the San Onofre kelp forest. The CCC required Southern California Edison, an artificial reef that was large enough to support at least 28 tons of fish and 150 acres of kelp, which was the estimated impact to the San Onofre kelp forest, along with the entire kelp forest community of kelp bed fish, invertebrates, and algae to compensate for all those losses in the kelp forest community. Another requirement the Coastal Commission had was to provide funding for scientific oversight and monitoring that was independent of Southern California Edison. And that's where we come in. That monitoring is done through a contract with UC Santa Barbara. This is our team of people that are required to do the monitoring. And this is a team for both projects, the artificial reef and the mitigation project. We have 6 different project investigators that lead different aspects of the project. We have a very competent scientific staff, trained biologists that are trained in kelp forests and wetland ecology. And we have a science advisory panel that gives us a lot of great insight and direction. And that consists of Professors Rich Ambrose from UCLA, Pete Ramundi from UC Santa Cruz, and Russ Schmidt from UC Santa Barbara, all who are in attendance today. Okay, well, the objective of this project is to replace the marine resources damaged or lost in the San Onofre kelp bed due to the operations of SONGS units 2 and 3. Most of you probably know those units are no longer operational, okay? But when they were operational for about 32 years. So the mitigation projects are designed to compensate for the loss of resources that occurred during those 32 years of operation. And so there's a series of steps that was used in the approach to this mitigation project. The first step in this project was to design an artificial reef and sandy habitat that was similar in low relief with topography and depth similar to the San Onofre kelp forest, all right? Is to create an artificial reef that kind of mimicked the reef that was impacted, right? And to locate that artificial reef near the power plant, so those resources would be replaced nearby, but outside the influence of that power plant, okay? Second component was to construct the artificial reef in 2 phases. The first phase would be a small, relatively short-term study that would be an experiment that would test different reef materials and designs. And the idea was information from that 5-year experiment would then be used to design the second phase of the project, which is a much larger phase that would be monitored for the period equivalent to the operating life of songs, 30 years or so. And the idea there was that collectively those reefs, the phase 1 and phase 2, would replace the kelp forest resources that are lost at San Onofre due to the operation of the power plant. Third, a method here is to monitor the artificial reef to measure its success based on performance standards that were developed largely by the California Coastal Commission to ensure that the project objective is met. And then to impose corrective measures if the monitoring showed that those standards are not being met. And then lastly, to end the project monitoring oversight after the mitigation requirement is met. And you'll hear more about what requirements are in subsequent talks later today. Okay, well, this map here on the right shows a location of the phase 1 and phase 2 reefs. They're located off the city of San Diego. The phase 1 reef consists of 56 40-meter by 40-meter modules. They're shown are these dark pink squares in the map here. Those modules were arranged in 8 different reef designs, arranged in 7 different blocks that extended around 3.5 kilometers, or what's that in miles? About 2 miles or so of coastline, something like that. And that was built in 1999. Phase 2 reef added an additional 150 acres of 18 irregularly shaped polygons of varying size, which are shown in green here. Those polygons were constructed of quarry rock and covered on average about 42% of the bottom. And the intent of the phase 1 and phase 2 reefs together, which comprised 175 acres, the idea was that that reef then would be used to mitigate, to compensate for all the losses caused by the power plant. These are some photos taken on the artificial reef. They show some of the more iconic marine life that's found on the reef. You'll see sand bass, kelp bass are 2 of the more common fish that comprise much of the biomass of fish on the reef. Spiny lobster are very abundant on the reef. They're also fished out there as well. And we also have species like the giant sea bass here, which are endangered species that are common visitors to the artificial reef. So monitoring the reef actually began in 2009, monitoring for the performance of the reef. And while the results showed that the 175-acre Wheeler North Reef was largely similar to natural reefs in the region in terms of the densities and cover of various types of organisms, the monitoring showed that the reef was just too small to consistently meet the performance standards that require the reef to sustain 28 tons of reef fish standing stock and 150 acres of medium to high density adult giant kelp. So in 2016, the Coastal Commission required Southern California Edison to remediate the Wheeler North Reef by adding up to 210 new acres of low relief reef. And this is referred to commonly as, we refer to it as phase 3 reef or the phase 3 expansion reef. This is a map showing where that phase 3 expansion occurred. It's shown in these white polygons. There's 20 of these, again, irregular shaped polygons. There's a few of them that are located on the inshore southern edge of the phase 1 and phase 2 reef, but the vast majority of the phase 3 reef extends north up coast of the phase 1 and 2 reef. So collectively, all 3 phases together cover about 373 acres. They cover about 45% of the bottom on average, largely of quarry rock boulder material. That's a low-lying reef, about 1 layer of rocks, and it extends around 4 miles or so of coastline, something like that. That extends north of San Clemente Pier down to San Mateo Point. The performance monitoring is done to determine whether or not the Wheeler North Reef is meeting its required project goals as determined by these performance standards that are set up. The sampling design consists of 151 stations on the different phases of the Wheeler North Reef. These black diagonal lines that you see in the polygons are actual locations of where the sampling stations occur. There's a total of 12 of those stations on the phase 1 modules, 80 on the phase 2 modules, and 59 on the phase 3 polygons. Each station is defined by a differential GPS coordinate and a compass heading, so we very closely try to sample the same locations over time. And the stations are all sampled once a year from beginning in summer and extending into early autumn. We use different types of sampling units to sample different types of organisms. Fish, for instance, are sampled along 50-meter long station, a meter and a half off the bottom. So the is designed to really capture reef-associated fish. Larger algae and invertebrates then are sampled in these 10-meter by 2-meter plots that are located uniformly along the reef. There's 5 of those along the transect line. And then smaller algae, invertebrates, and fish are either counted within a 1 meter squared quadrat within those, or their percent cover is estimated depending on the type of organism. We have I think actually it's a very nice website. It has a lot of information about the project, the background, the history, the purpose for both the wetland and the artificial reef projects. We have a library on this website where you can go to and you can find all different types of documents. We have a browse and sort feature on here that allows you to sort documents by the project type, whether it's artificial reef or wetland, by the authors of it, and various types of documents that range from annual reports. We create annual reports every year on both project. We house those on the website. There's various monitoring plans. There's various agency documents, as well as annotated PDF files of these workshop presentations. Along with a link to, I should have mentioned, a link to a video recording of this presentation. So just so you know, this is being recorded. There'll be a link on the website if people want to watch the recording at some other point in time. Also on the website is a data catalog. All the data that we collect, we go through a lot of length to make sure we have very high quality data products that go through a very rigorous data quality control. Those data products then are put together with metadata that describe the data, along with documents that discuss how the data are collected. All these data then are archived in the Environmental Data Initiative's data portal, which is run by the National Science Foundation. You can access the data either directly through that data portal, or you can go through our data catalog, where you can more easily browse through the data types by the different habitats. We have different types of data sets. We have what we call survey data sets, which are largely they're data that haven't gone through a lot of manipulation, say, where we also have a lot of derived data sets that we use to evaluate the performance standards. The data sets are broken down by various taxonomic categories or various physical features that we measure as well. So if you want the data at all, they're very easy to access. They get updated every year. And also, if you want to stay in touch with our project, you can sign up on our website. This is the homepage of the website. You can sign your name to our mailing list. We have Instagram and Facebook, just Instagram. We have contact information in here. So anything you want to know, please get a hold of us, and we're happy to share all that with you. So with that, I'd like to turn it over to Kat Beheshti, and she's going to report on the results from last year's monitoring of the Wheeler North Reef.
Okay, thank you, Dan. All right, so like Dan mentioned, this talk focuses on the 2022 monitoring results and the performance of Wheeler North Reef. So just to review, the goal of Wheeler North Reef is to compensate for the kelp forest resources lost due to the operation of SONGS Units 2 and 3. And there are a variety of physical and biological variables that are evaluated every year to determine whether or not these goals are met. In particular, there are 3 types of performance standards that are evaluated to determine the success of Wheeler North Reef in meeting its goals. So the first of these is the relative performance standards that require Wheeler North Reef to be similar to reference sites every year. The second are absolute performance standards measured at Wheeler North Reef only that must be met every year. And the third are absolute performance standards measured at Wheeler North Reef only that accumulate mitigation credit over time until a required value is met. So evaluating the relative performance standards requires comparing Wheeler North Reef to nearby reference reefs in the region. And so choosing appropriate reference sites was a critical element of the mitigation project because they serve as the basis for determining whether or not Wheeler North Reef is successful in meeting its goals. And so the criteria used to determine whether or not a potential site was appropriate for consideration was that it needed to have a history of sustaining giant kelp. It needed to occur at a depth similar to that of the artificial reef, be primarily low relief, preferably consisting of cobbles and boulders, and be located within the local region, but not affected by SONGS. And the kelp forests at San Mateo and Barn were chosen as having best met those criteria. So the SONGS Coastal Development Permit envisioned a quantitative definition of similar. And so the permit also specified that definition be outlined in the monitoring plan for the mitigation project. And so after much discussion, the definition of similar that was adopted was the one listed here, that the 4-year running average for a relative performance standard at Wheeler North Reef must not be significantly less than that at the reference reef having the lowest value for that performance standard. And so this definition recognizes that no 2 reefs are identical, but that any chosen reference reef should serve as an acceptable target. It also acknowledges that the biological characteristics of reefs from year to year vary substantially and that there's error associated with any sampling design. And so by using a 4-year running average, we're accounting for this variability. So we're going to briefly mention how our performance monitoring was impacted by COVID-19. So university-sponsored research was shut down from mid-March to mid-July, causing a large reduction in sampling effort in 2022. And so as a result, the 2022 data were excluded from the 4-year running average used to evaluate many of the performance standards. So when we refer to the running average for many of these standards, we're referring to an average for 2019, 2021, and 2022. Okay, because natural kelp forests vary substantially from year to year with respect to species composition and abundance, it's likely that the reference reefs would not meet all relative performance standards in any given year. And so as not to require Wheeler North Reef to perform better than the reference reefs, Wheeler North Reef is only required to meet as many relative performance standards as the lowest performing reference reef. And this achieves the desired goal of not requiring Wheeler North Reef to outperform reference reefs, but requiring it to be similar to them. And so this method that we use to evaluate the relative performance standards is that we take Wheeler North Reef and the reference reefs and we evaluate them with respect to each other to determine whether they meet each of the relative performance standards, of which there are 11. And so the total number of relative performance standards met by each reef are then tallied and compared to one another. So here's the list of the relative performance standards. Standards 1 through 5 pertain to algae and invertebrates. Standards 6 through 10 pertain to reef fishes. And then standard 11 integrates the benthic community with reef fishes to examine the extent to which the benthic community supplies food for reef fishes. Okay, so I'm going to briefly orient you to these graphs because you're going to see a full set of them in the coming slides. So on the left, we have our annual time series for any given relative performance standard from 2009 to 2022. Consistently across the top, Wheeler North Reef is color-coded in green, Barn in blue, and San Mateo in red. And then the plots on the right are the 4-year running averages. And we've indicated in the bars whether any given standard, the reef, either of the 3 reefs passes or fails. And so here we're showing percent cover of macroalgae on the top and number of species measured as the number of species per transect for macroalgae on the bottom. And so just looking at these both together for a second, generally what we've seen is an increase in both percent cover and the number of species of macroalgae across Wheeler North Reef. But Wheeler North Reef has been consistently below that of the reference reefs over time, with the exception, I'm going to try and get this so that. All right. With the exception of 2009 and 2021 and 2022, where Wheeler North Reef supported similar numbers of species of macroalgae to San Mateo. But again, being consistently lower than the reference reefs, especially if focusing on the last 4 years and looking at the 4-year running average, San Mateo and Barn passed 22 and Wheeler North Reef failed both standards. So plotted first on the top, we're going to focus on the top 2 graphs first. We see this is the percent of bottom covered by sessile invertebrates. So sessile invertebrates compete for space with macroalgae, and where macroalgae get their food from photosynthesis, sessile invertebrates filter the water column and eat via phytoplankton in the water column. And so what we see when looking at percent cover of sessile invertebrates is that Wheeler North Reef has generally been well within the range of the reference reefs. And since about 2016, across all 3 reefs, it's been relatively similar. And so if you look at the 4-year running average on the right, all 3 reefs passed this standard in 2022. Now moving to the bottom graph, which is for mobile invertebrates, measured at the density of mobile invertebrates per meter squared. We see that Wheeler North Reef has been, with the exception of the first 2 years following the construction of phase 2, well within the range or above that of the reference reefs. And looking at the last 4 years, you see that Barn has been consistently lower, and San Mateo and Wheeler North Reef have been the higher of the 2 reefs with respect to the density of mobile invertebrates, which is reflected in the 4-year running average, where we see Wheeler North Reef and San Mateo passed this standard and Barn failed. So here we're showing the number of species per transect when we combine both sessile and mobile invertebrates. And you can see that there were comparatively few invertebrates that inhabited Wheeler North Reef in the first few years following its existence. But by 2012, Wheeler North Reef was very much well within the range of the reference reefs. And when we look at what happened for the 4-year running average for 2022, we see that Wheeler North Reef and San Mateo passed the standard in 2022, and Barn failed it, but you can see that it just had slightly but significantly less number of species of invertebrates compared to either of the other 2 reference reefs. Okay, so now we're moving away from inverts and now to fish. So plotted on the top are the density of resident fish, which are measured based off of the size of the fish. So we take our diver data and based on the size of the fish, we determine their age. And so resident fish are individuals that are greater than 1 year in age. And what we see is that Wheeler North Reef, or all 3 reefs, have been relatively stable over time with respect to fish density, and that I don't know where my voice is going. That's weird. And that if we look at from 2016 or 2017 on, Barn and Wheeler North Reef have had consistently higher densities of resident fish relative to San Mateo. And so that's reflected in the 4-year running average, where both Wheeler North Reef and Barn passed and San Mateo failed. A little bit of a different pattern when looking at young of year or yoi fish density, where we see that density has fluctuated pretty sporadically from about 2009 to 2016, where they all dropped across all 3 reefs. And then since then, we've seen it be densities be relatively low, with the exception of the last few years, where we've seen a steep increase in yoi density at Wheeler North Reef and less so at San Mateo, which is reflected in the 4-year running average, where Wheeler North Reef and San Mateo passed and Barn failed it. Okay, so now we're looking at the number of species of fish across all 3 reefs, and we can see this one's really clear that Wheeler North Reef has been well within the range of the reference reefs. San Mateo generally has fewer species of fish relative to Barn, And that's reflected in the 4-year running average, where both Wheeler North Reef and Barn Pass and San Mateo failed this standard in 2022. So next we have fish production, which is measured as fish biomass per unit area in any given year. And this is a standard that integrates both somatic and gonadal growth. And so somatic growth is estimated by taking the widths, measuring the widths of the annual rings and the ear bones of fishes. And gonadal growth is measured by measuring the production of tissue associated with reproduction, which can be quite large. And so we see that over the entire time series, across all 3 reefs, fish production has been relatively stable from about 1 to 5 grams per meter squared per year, with the exception of 2011 at Barn, where production of all 5 species that are evaluated for this standard was higher at Barn. So these 5 species are black surf perch, blacksmith, California sheephead, kelp bass, and Chirita, thank you. Yeah. And so, so they've all been relatively stable over time, but you can see that SMEC's been the reef that has consistently had the lowest fish production. And that's reflected when looking at the 4-year running average for 2022, where Wheeler North Reef and Barn passed the standard and San Mateo failed it. Okay, so next we have fish reproduction on the top. And so fish reproduction is measured using an index for female fecundity, which is what we call our fecundity index. And this is the mean egg production scaled to female size in a given year. And you can see that there's been really no clear series. And as a result, when looking at the 4-year running average, all 3 reefs passed this standard in 2022. As a reminder, food chain support is the standard that integrates the benthic community and tries to determine the extent to which the benthic community is supplying food to reef fishes. And so for this standard, we use a food chain support index where we measure the gut contents of 2 species, black surf perch and California sheephead. And what we see is that food chain support has been relatively constant and stable over time for the full duration of our monitoring. And that when we look at the 4-year running average, San Mateo failed the standard because it had slightly but significantly lower value for food chain support that was driven by this steep decline in 2020 that drove down the 4-year running average for this standard, whereas Wheeler North Reef and Barn passed the standard in 2022. So this slide summarizes the number of standards met across all 3 reefs in 2022. Where Wheeler North Reef met 9 of the 11 standards, which is 1 more than Barn, and 2 more than San Mateo, which is the lowest performing of the 2 reference reefs. And this indicates that Wheeler North Reef is functioning similarly to reference reefs in the region. And because Wheeler North Reef met at least as many, it met 2 more, but at least because it met at least as many relative standards as the lowest performing reference reef, this mitigation requirement was met. So now we're going to pivot to the second type of standards, which are absolute performance standards that are measured at Wheeler North Reef only, that must be met every year. So these standards are the standard for hard substrate, which states that at least 90% of exposed hard substrate remain available for attachment by reef biota, and a standard for undesirable and invasive species not be undesirable and invasive species. And for these 2 standards, the way that these are evaluated is it's based on the value measured in the current year or the 4-year running average, whichever is higher. So for each, we're going to in our approach, starting with the hard substrate. So first we use sonar surveys that measure the footprint area of Wheeler North Reef for phases 1 and 2 only, and we get the footprint area. We then have diver surveys that collect data on percent cover across 5 1-meter squared quadrats across all 82 transects. And so that percent cover data and the footprint area, the product of those 2, gives us the area of exposed rock. We then compare that area of exposed rock to the value measured shortly after the construction to determine whether or not 90% or more is available for attachment by reef biota. And our divers collect data on substrate that ranges from any of these 9 categories, but the ones that are used for evaluating this standard are of cobble size or greater. And so this figure on the left is showing the area of hard substrate over time. We have the 90% threshold here as the dotted line and the initial as-built as the solid line. And you can see that when looking at either the current year or the 4-year running average, Wheeler North Reef has been above that 90% threshold. And so this standard passed in 2022. And just to point out that values above that initial as-built are likely driven by redistribution of reef material or scour. Okay, moving on to the invasive and undesirable species standard. First, use the term here. Undesirable species are native species that can become very abundant and impair important reef functions. So an example of this could be high densities of sea fans, which can monopolize space and exclude other species like macroalgae, giant kelp, for example. And then the other example are high densities of sea urchins, which when they get abundant enough can cause these grazing fronts that convert kelp forests to urchin barrens. Whereas invasive species are non-native species that become abundant and can either exclude native species or impair important ecosystem attributes or functions. And so examples of this would be the green alga Caulerpa prolifera or the brown alga Sargassum horneri. So this standard is really focused on potential impairment of important reef functions. The chosen functions that we focus on for this standard is first the primary production of giant kelp and also the secondary production by reef fishes. So those are the focus functions we focus on for this standard. And we estimate giant kelp production using our diver data on kelp frond density, which serves as a proxy for kelp net primary production. So for evaluating this standard, we take a three-pronged approach where first we measure the abundance of both undesirable and invasive species at Wheeler North Reef relative to the reference reefs to determine their potential to impair important reef functions. The next step is to compare the production of giant kelp and fish at Wheeler North Reef relative to the reference reefs to determine whether these functions at Wheeler North Reef are underperforming relative to the reference reefs. If the answer is yes, Wheeler North Reef does have a lower performance of these functions, we move on to step 3, which is so then we can complete additional analyses and studies to determine whether underperformance is causing impairment from undesirable and invasive species. So focusing first on the first step. So on the left, we're showing the percent cover on rock of sea fans across all 3 reefs. And you can see that sea fans have increased Wheeler North Reef disproportionately relative to the reference reefs. And so this is potential cause for concern that there may be impairment of important reef functions by sea fans. Alternatively, when we look at the density of sea urchins on the right, we see that Wheeler North Reef has had relatively low densities, less than 1 per meter squared for the entire duration of our monitoring. And this is well below the threshold required to convert kelp forests to urchin barrens, which is estimated to be between 20 and 30 individuals per meter squared. So there's little concern at this point in time that there may be impairment of reef functions by sea urchins. It's also important to note that we observed no invasive non-native benthic macroalgae in 2022 on Wheeler North Reef. And so at this point in time, there's no concern that there may be impairment from invasive non-native species. So given the high abundance of sea fans, we move on to step 2, which is to compare these 2 functions at Wheeler North Reef and the reference reefs. And so plotted on the top is giant kelp primary production. And what you see is that Wheeler North Reef has been well within the range of reference reefs, with the exception of 2009, which was 1 year following construction of phase 2. And so, and this is reflected in the 4-year running average, where Wheeler North Reef supports higher kelp production than San Mateo, but lower production than Barnes. So it's intermediate in terms of the kelp production, looking at the 4-year running average. And when looking at fish production, which is our second function that we're concerned with, Wheeler North Reef has again been well within the range of the reference reefs. And that's 2 is reflected in the 4-year running average, where it's the intermediate of the 3 reefs, having higher fish production than San Mateo and lower fish production than Barn. And so what this means is that there's no really compelling evidence that undesirable native species or invasive non-native species have impaired important functions of Wheeler North Reef in 2022. And so this standard passed in 2022. Nonetheless, given the abundance of sea fans on Wheeler North Reef, we're going to continue to closely monitor their abundance and their potential impact on these 2 functions that we're concerned with. Okay, now we're focusing on the last set of standards, which are the absolute standards that accumulate mitigation credit on an annual basis. And so the performance standard for giant kelp is based on the intent of Wheeler North Reef to sustain 100 medium to high density adult giant kelp for a time to the full operation of songs units 2 and 3, which is 32 years. Similarly, the fish standing stock standard is designed to address the intent that Wheeler North Reef support 28 tons of fish standing stock for a period of time equivalent to the 32 years of Song's operation. And so the way that these standards are evaluated is that the annual standing stock of fish and the acreage of giant kelp at Wheeler North Reef are measured every year and summed over time until they reach a cumulative total that is equivalent to the annual target, so 150 acres for giant kelp and 28 tons of fish standing stock times the number of years of Song's operation, which is 32 years. And the accumulation of credit began in 2019, as was decided by the California Coastal Commission. So we use medium to high density adult giant kelp are that we have divers record their density in a fixed 100-meter squared area within each of the 151 transects. So these 2 standards, fish standing stock and giant kelp area, are evaluated on basis of Wheeler North Reef. And here, medium to high density is defined as having greater than 4 adults per 100 meters squared, and adults are defined as individuals with more than 7 fronds. And so what we do is we take the proportion of transects that have medium to high density adult giant kelp, and we multiply that by the footprint area of Wheeler North Reef to get the area of adult giant kelp on the reef. So plotted on the left is the area of adult kelp from 2019 to 2022, which is the year that this standard began to accumulate credit. And these are the annual values. And we have the 150-acre design target shown at the top in the dotted line. And then on the right, we have the cumulative kelp acres. So how that has added up over time. And we have the mitigation requirement, which again is 150 times 32 years, which is 4,800 acres. And so in 2022, Wheeler North Reef 77 acres of giant, medium to high density adult giant kelp, resulting in a cumulative total of 164 acres. So 77 acres is the most that we've had since 2019, but it's still well below the 150-acre design target, which might be of potential concern. And so when looking at the density of giant kelp across all 3 reefs, we see that Wheeler North Reef, again, has been well within the range of the reference reefs, oftentimes well above the kelp supported by the reference reefs. And so this indicates that Wheeler North Reef is supporting giant kelp characteristic of the region in general, and that the decline that we've been seeing since about 2017 is not specific to Wheeler North Reef and more characteristic of the region. Okay, moving now to the methods used to evaluate fish standing stock of reef fish. So we apply species-specific length-weight relationships to fish density and size data that are collected by divers to calculate the average biomass density of all fish near the bottom from all transects within a polygon. We then take each of them to get a scaled-up estimate of fish biomass that is for the entire footprint area of Wheeler North Reef. So similar to what we saw for kelp, on the left, we have fish standing stock from 2019 to 2022 with our design target as the dotted line here at 28 tons. And on the right, we have the cumulative fish biomass. And we see that in 2022, Wheeler North Reef earned mitigation credit for 26 tons of fish standing stock, resulting in a cumulative total of 94 tons. And this is below the mitigation requirement of 28 tons that was met last year. So looking at similar to what we did for kelp, looking at fish biomass density across all reefs, we see that Wheeler North Reef is well within the range of the two reference reefs and and so of comparable size. And so this indicates that Wheeler North Reef is supporting fish standing stock that is equivalent to similar reefs that are of same size as they are. Okay, so to review how we assign mitigation credit, breaking it down by these three different types of performance standards. So again, the goal of SONGS mitigation is to compensate for the kelp forest resources that were lost due to the operation of SONGS units 2 and 3. And so when it comes to the relative performance standards and the absolute performance standards that must be met every year, so hard substrate and undesirable and invasive species, 1 year of mitigation credit is given for every year, for each year that Wheeler North Reef meets both of these standards. And so fulfillment of this mitigation requirement occurs when the number of years of mitigation credit accrued by Wheeler North Reef equals the total years of SONGS operation, which was 32 years as determined by the commission. Alternatively, the absolute performance standards that accumulate mitigation credit over time, so giant kelp area and fish standing stock, are evaluated separately and assigned mitigation credit independent of the first two standards. And so fulfillment of these mitigation requirements occurs when the total accrued mitigation credit for a given standard equals the targeted annual value, which is 150 acres or 28 tons, times the total years of operation for SONGS units 2 and 3, which is 32 acres. Okay, so this slide summarizes the earned mitigation credit for 2022. So in 2022, Wheeler North Reef earned 1 year of mitigation credit. Since 2019, they've earned 4 years, the reef has earned 4 years of mitigation credit, meaning that it still needs an additional 28 years to reach the 32-year requirement to fulfill this mitigation requirement. Alternatively, when we look at the performance standards that accumulate credit over time, Wheeler North Reef earned 77 acres of credit in 2022 for giant kelp area, leading to a cumulative credit of 164 acres, meaning that it needs an additional 4,636 acres in order to meet the required acreage. So, fish standing stock earned 26 tons in 2022, contributing to a cumulative credit of 94 tons, meaning that it needs an additional 802 tons to meet the required 896. Okay. And so with that, I know there's a lot of information. I'd be happy to take any questions now on this talk or the talk that Dan gave on the introduction. We have any questions, Dan? No. Yeah.
I have a question. What is the annual variability of the kelp? Because I know you said you had to go out once per year. Does that impact your analysis?
Yeah, exactly. So kelp it's more productive during certain times of the year. We get that peak window with most of our monitoring season, but it's true that some recruits come in at different times and some adults grow and can become adults later in the season. So it does vary, but we try and survey the reef so we try not to survey only the northern part of the reef all at once, so that we're capturing some of that variability that does occur over time with respect to kelp growing. But Dan, do you want to?
I guess I would just add to it. Each station is sampled once a year, but the amount of time it takes us to sample all the stations, which is 82 stations at each of the reference sites, and then 151 at Wheeler North Reef, kelp gets sampled from about end of May, early June, all the way into early October. So we do cover a much longer period for the monitoring, but each station is only sampled once. And as Kat said, we make sure that there's no bias as to when different reefs are sampled. They're all sampled simultaneously through that 5-month period.
Yeah.
How do you say that the all three phases together is 4 miles?
Yeah, so the question was, is it the case that all three phases span about 4 miles? And that's, yes, that's correct. It's like 3.5.
7 kilometers, which I'm
Yeah.
trying to do the math in my head. It's
I think it's 3.5.
A little over 4 miles. So it extends from San Mateo Point up about 2 miles or so above San Clemente River.
Oh, okay, and then how far out from the shoreline is it?
About a kilometer, which is about 2/3 of a mile, something like that. About 1,000 yards or so offshore.
With that, those two questions, do you ever have recreational watercraft going through and looking, and is it causing problems for your monitoring, or is it interfering with growth of the marine life?
I guess I would say during the design of the artificial reef, there was input from the public. And one of the concerns raised, particularly by the commercial fishermen, is that if it was a solid reef, it would be difficult to navigate through there, particularly fishing. So that's why you see the reef broken up into these kind of polygons and modules. So there's kind of navigational channels. There is boat traffic out there, but there's boat traffic out everywhere. The boat traffic, I don't think harms life on the bottom at all. Boat propellers do cut kelp that's at the surface, but kelp grows very quickly, and the impacts of cutting some of the canopy at the surface to what we're measuring is probably undetectable. And probably has virtually no effect on the long-term biomass of the kelp
Or our monitoring, yeah.
or on the area of.
You have been monitoring. Thank you.
Yeah. Sorry, I'm gonna repeat the question for people that are remote. So the question was, does any boat traffic that goes over the reef affect our monitoring or the performance of the reef? And the answer that Dan gave was generally no. Yeah. Did you have a follow-up?
Well, I was teasing you about something. You know.
Oh. I missed it.
But I did go to follow up with Commissioner Campbell-Piano's question about the kelp growth. What about the marine life too? Is it seasonal that you go out and monitor marine life? How do you go out there for those periods where you monitor everything?
Why do we do the monitoring when we do it?
Yes,
Um,
are the different kinds of stations that you go to for the phases with the different marine life, et cetera? Do you do those all at the same time in the same point of time? Or do you do it based on their breeding time or whatever?
Yeah, no, I think
Dan,
it's,
you wanna
I
repeat the
think it's
question?
the former. It's not based on breeding time. What happens with the fish, unlike the organisms that live on the bottom, sampling the fish requires a certain amount of underwater visibility. And what we often see is that early in the sampling season, the visibility is not good enough. We have a criteria that there has to be 2 meters or so of visibility before we'll actually collect data on the fish. Is it 2.5? 2.5 meters. And often in the spring, you get a lot of upwelling, a lot of clarity. It's just not good enough to do that. So in the end, with the fish, what happens is most of the sampling for the fish, most of the sampling stations get surveyed later in the sampling period than early, because we're just not able to get at the fish. But the benthic community, the kelp, they get sampled pretty uniformly throughout that whole period. There's seasonality in the kelp forest like there is everywhere, but that seasonality does not create any bias when we're comparing the sites to each other, because they all get sampled at the same time.
My comment about the fish for production and reproduction.
Yes. You want to answer that? or-
Yeah, so
The question, to repeat the question, how does seasonality
Yeah.
impact our sampling and the performance standards? And Rich is going to ask how that might affect performance standards when it comes to the reproduction of the fish or the growth and production of the fish.
right, so those are not sampled the same as most of the other things that we've been talking about. it's sort of a special directed effort to focus really just on the time period when the fish are reproductive. So, and capturing fish throughout that whole season, so that we get the whole reproductive period that feeds into fish production.
And the growth estimates for the fish are done by looking at annual rings in the ear bones. And so that really those fish can be collected, or those rings analyzed at any time of year to get those growth increments. So.
Yeah, I already asked.
No, go for it.
But I had a question about, if there's been analysis to see if what Wheeler Reef is producing as far as kelp forests, how that's contributed to the overall, I guess, kelp forest population in Orange County, because I've read things like 90% of our kelp forests are gone. So I'm wondering if what percent is Wheeler Reef bringing back? Is that part of what you're looking at?
I mean, we don't directly look at that, but we have the data to be able to answer that question.
Question, repeat.
Oh, yeah, so sorry. So the question was that, Orange County has lost a huge proportion of its kelp, 90%. And so are there any evaluations of how Wheeler North Reef is adding kelp that was previously lost to the region? Yeah.
So I guess I would add that whatever Wheeler North Reef is contributing wouldn't be there if it wasn't for the artificial reef. Okay, so it's an addition. What you saw in some of the data that Kat presented when it came to, say, the fish biomass in the kelp area, Wheeler North Reef is doing about as well as the natural reefs. What fraction that's contributing to, say, the kelp beds in Orange County, we've not done that calculation. It's something that it would be harder to do it for fish biomass because those data aren't out there. One could do it for kelp area using satellite imagery. And so we could look at that potentially. Right now, there's not a lot of, particularly after this winter storm, there's virtually no kelp out there at all.
And in this year, in 2022, Wheeler North Reef supported more kelp than either of the two reference reefs. So in that way, it's contributing what would have already, like Dan said, would not have been there because it was just sandy bottom. So it is adding that 77 acres, at least in this last year.
Yeah, I have a question online.
Okay.
The question is from Chris Goldblatt. I'm going to allow.
Yeah. Hi, everyone. Hi, Kat. Hi, Dan. Thank you so much for a wonderful presentation. You guys hear me okay?
Yeah, we can.
Fantastic. So 2 questions and a quick comment. First of all, I want to thank everybody involved in this, from the Coastal Commission to Edison to UCSB, because it really is a world-class reef that you guys have made. To my knowledge, it's the largest kelp afforestation project in the world with hard, tangible results and extremely good science that's occurred on it. A lot of that science will parlay into the future, into the project I'm working on. And it's really nice to have a solid, high benchmark to work with. Plus, when this was envisaged, carbon sequestration wasn't part of it, but it's a major carbon sink. The science that we proved out shows something like 2 tons of carbon per surface meter of kelp per year, something on that order is sequestered, and that's a major component moving forward. But my 2 questions are this: have you seen an increase in average lobster size as the reef has aged? That's the first question.
So the question was, have we seen an increase in average lobster size as the reef has aged?
We don't collect data on the size of the lobster. We do collect data on the density of lobster. And boy, that's in the annual report.
Yeah.
I think what that graph is, but I can tell you that the density of lobster on Wheeler North Reef compared to the 2 reference reefs is more than double. And it's been increasing in the last few years. I think there's data from work that we've been doing up at Santa Barbara that shows that lobster densities in general have been increasing through much of Southern California, particularly some of the catch data as well. It may have something to do with the warmer water, but we don't have data on size. We do have data on density, and density has been increasing.
Okay.
Yeah.
That
So-
was Mhm.
So if you look at our annual report, like Dan said, I have it right here, but the densities have gone up to 4, basically around 4 individuals per 100 meters squared.
which
Okay.
is quite high.
There's a lot of them.
Yeah.
Yeah, that is a good number. Thank you for that. Because that's an important question, because the Point Loma kelp beds have millions of lobsters and they're all a 1/4 inch under legal. You could see a cloud of 1,000 lobsters in a hole and there'll be one legal one in there. That's why I asked that question. And a lot of it is just because of the size of the interstitial area that they access, that basically the cave size. My next question is a little bit more abstract. When it comes to the optimal distance between functional holdfasts, have you guys found that there's some kind of magic ratio there in terms of the distance between it and things that might affect it, such as, let's say, a sand channel that has been placed between it? Does that create more or less, or is it the shape of the rock? And how does that correlate with the CFAN issue? So if you have higher density of kelp, do you have more CFAN because you have less light penetrating, for the understory to grow?
Yeah, so in terms of optimal distance among kelp, is this optimal in terms of what's best for kelp, or is this, I'm not quite sure what you mean by optimal. Because what happens with kelp, and Chris, you probably are aware of this, like after a winter like we've had now, it's not uncommon to see very dense colonization by kelp. And so you get really high densities of small plants. And what happens over time is those small plants thin out and the spacing among plants gets larger, but the plants themselves get larger. And the biomass of kelp may not change, but the way that biomass is distributed on the bottom and through the water column changes. And that just happens as a successional sort of sequence as the kelp bed matures over time. The canopy that's there, whether it's produced by a lot of small plants or a few large plants, that canopy suppresses the light that reaches the bottom. And that light that reaches the bottom suppresses all the other algae that compete for the invertebrates, for space on the bottom, including potentially CFANs. Now, the thing with CFANs is they're relatively long-lived, where other sessile invertebrates, such as bryozoans and tunicates, are more ephemeral. And so they're more likely to be influenced by fluctuations in the biomass of kelp through shading than CFANs are, that are able to persist periods of dense kelp canopy versus low kelp canopy. And so I suspect that the shading aspect of kelp would only affect CFANs during the period when CFANs are recruiting as small individuals. But once they get large, they're probably more impervious to fluctuations in the canopy of kelp, mainly because, except to the extent to which canopy reduces their food supply by altering currents. And that may reduce, say, the growth of colonies or the recruitment of new kelp or new colonies.
Got it. So, but would you say that there's less CFANs that occur in areas where there's a break in the reef structure and there's more light penetration?
Well, where there's a break in the reef structure, you don't get reef organisms. So there's no CFANs. A break in the reef structure, meaning a sand channel.
Yeah. So on the edge, let's say on the edge of a sand channel, that's what I'm getting at. Yeah.
Yeah. So is the distribution of CFANs differ on the edge of a reef module versus the center of a reef module?
Right.
Is that kind of?
Yes.
I don't know the answer to that. Does Pete?
No, but I think you might think about, you can comment on this directly, but the period when the most accumulation of CFANs occurred in Wheeler was early on, right? It was dark. I mean, the canopy was lush, and then the cover's gone up, but the numbers have flattened out since. That's my memory of the CFAN phenomenon in Wheeler. It came in when it was really dense canopy. Since then they've grown, but there hasn't been major recruitment pulses since.
Gotcha. So Chris, I don't know if you heard Pete's comment there, but his point was that the densities of CFANs have not gone up appreciably over the years, but the graph that Kat showed was on the percent cover of sea fans. So we got very dense recruitment of sea fans, and that occurred at a time when there was actually fairly high density of kelp.
Mhm.
But the cover of sea fans has gone up because the sea fans have grown and gotten bigger and have occupied more space.
Mhm. Mhm. Okay, thank you so much.
We've not explicitly looked at the distribution of sea fans on the edges of the reef versus the middle of the reef. We could try to tease the data part that we have to look at that, but we don't have great sampling on the edges versus the interiors of the modules. So our data may not be the best data to answer that question.
Yeah, it just seems like such a important variable, like in Santa Monica Bay, where it's all sea fans on those artificial reefs. And then you go over to barn kelp and you see a lot of it, you know, in the heavy part of it. And I'm just trying to determine what the causal factors are for, you know, why certain reefs basically get taken over by sea fans and some don't.
Yeah, that's a really good question. I know before the artificial reef was built, there was a lot of sighting done by both Edison, Haniawani's group, and we did some dives as well. There was sporadic boulders and stuff throughout all that sandy area where the reef was built. And I know, looking back in my dive notes, there was sea fans on those sporadic boulders. So
Mhm.
I suspect that the location area, for whatever region, the region where San Mateo is and where the Wheeler North Reef is, it's a good area for the recruitment of sea fans, and barn kelp probably much less so.
Mhm. Mhm.
But I don't know why that's the case.
Yeah, very good. Okay, thank you so much. Keep up the good work, guys.
All right.
Thanks for the question, Chris.
I have a few more questions on line.
Okay.
The next question is from Susie Whitlow.
Hello, can you hear me?
Yeah, we can hear you, Susie.
Okay, great. I'm representing a group called Save Our Beaches San Clemente, and I'm kind of approaching this not from the productive aspects of the reef itself, but the potential that the construction of the reef and the growth of the kelp on the reef could have had an impact on our coastal erosion, which, as you know, is kind of a real hot point with our stakeholders here right now. And I'm a PhD myself in geology, marine geology, and I've done research on coastal erosion, marine sediment dynamics. And giving it some thought, I've thought of a couple of ways in which the reef might potentially have been impacting either the waves and erosion or redeposition of the sand within our system. And I was wondering if those ideas had occurred to you, or if you had any specific research or lights to illuminate on it.
That's a great question, Susie. Is that your question?
No, I have some more specific.
More? Okay, more. Okay.
Okay. Number one is that the 2019 placement of the reefs, especially in the southernmost end, were nearer shore and in shallower water than originally planned. And my question is, could these potentially both the rocks and the kelp growing on the rocks potentially cause a wave refraction, especially we get most of our erosion down there during the south swell events when there's really very significant swell heights. The San Mateo Point itself also forms kind of an underwater headland, and if wave refraction was causing some constructive wave interference and potential for wave intensification. I know some of the natural reefs around the pier in San Clemente were causing wave refraction and intensification and some of the damage done to the pier in past years. So I'm wondering if that's a possibility that you've looked into.
So Susie, we have one of the world experts here on coastal processes, wave refraction and kelps, Dr. Haniawani from Scripps Institute, and I think he will answer your questions for you.
Yeah,
Great.
let's get it.
Here, honey, if you come closer to here, and then they can hear you a little better.
Okay, well, let's first get your question, one question by another question, so we can give you the right answer for it, right? First, we have carried studies in 1995. It was really a huge, big experiment to study the impact of the kelp reefs on the waves, right? And when we talk about kelp reefs, we talk about kelp reefs having sizes, right, similar or larger, slightly larger than the size of the Wheeler North Reef. And what we find out that our kelp does not change the wave characteristics. And the wave characteristics actually, including the height, the directions, and the period. We have no positive or negative impacts on the waves, right? So in this concern, we do understand that we don't have impacts on the beaches corresponding. However, we didn't satisfy with that. We carried another study where we looked for the beach widths in front of the kelp reefs, up coast the kelp reefs, down coast of the kelp reefs, along the whole Southern California islands. And that's been, from historical data, been done by Professor Wheeler North Reef. We didn't find any impact for the kelp on the beaches. The studies are published in a very highly qualified reviewed journals in 1995. I'll be happy to give you a copy of your questions. So the fact is that the waves, the waves does not really feel the kelp at all. They go through. The reason for this, because the kelp is very compliant. And what means being compliant is to turn. It turn without any resistance for the waves. So that's really what I know for time being. I think another question was about San Mateo.
Oh, that just San Mateo also would create a refraction, and those two refracted waves then could have a constructive wave interference.
Okay, well, let's talk about wave refractions. Wave refractions happen because San Mateo is what you call it headlands, right?
Yes.
The bathymetry, the bottom bathymetry in front of it is really parallel to the shape of the headland, right? So they are not straight. So when the waves comes from both directions, it does refract on San Mateo. Is that has effect on the beach at San Clemente or south of San Clemente? No, it has some effect on the point, if it has an effect on the point. The fact is that the headland, or what we call San Mateo, or the penetrations of the land into the ocean are very small, doesn't make a really big refraction, because as an effect of that is we don't see erosions at San Mateo. We don't see erosion in both sides of the headland, right? Okay, so why doesn't it have impacts on San Mateo Beach? Because the sediment comes to San Clemente Beach from San Juan Creek, and it moved to the south. San Juan Creek is located, I think it's located south of Dana Point, so it's located for the south.
Right.
I see south of south of Dana Point. Yeah. So therefore, I would expect the impact of the San Mateo on the beaches is insignificant.
I thank you very much for your explanation. I beg to differ. Since 2019, a 100-foot long wide beach has been eroded and has completely disappeared. And the erosion has occurred during the South Swell events. And the sand has not moved north or south. We believe it's moved offshore. And that's what I'm talking about. There's been enormous amounts of erosion has taken place since those rocks were placed. And then I guess my follow-up question is, if the kelp aren't affecting the wave refractions, the 2019 placement there did place the rocks in shallower water and closer to shore. And could the placement of the rocks, basically you're shallowing the seafloor, you're creating a shallower seafloor. And so for larger wave events like that during the South Swell, we had very large, I don't remember offhand what the wave heights were, but they are really getting larger and larger. And could that potentially create a wave refraction?
Okay, here's the answer for you. The answer for you is very simple, right? Our rocks are very, have a small height, less than 1 feet and 1.5 feet. Secondly, when we done our experiment, the reef wasn't there. So we went for a similar reef, which is similar to Wheeler North Reef, which has rocks on the bottom, and we carried the experiment, right? So when we choose the reef, we choose the reef which have similar characteristics, and we never saw changes in the angle, because the change of the angle is indications for the refractions, right? Or anything before and inshore and offshore of the reef. I hope that answered your questions. I mean, there's no evidence.
Yes, thank you. Yes, I would really appreciate being pointed to the research for that. I had not seen that before. That would be really helpful. Thank you.
Yeah, I will be very happy. I mean, if you give your names to them, I'll give you a couple of papers to read. I'd be happy to do that for you.
Okay.
Thank you.
I have a second question, just kind of representing all the stakeholders that are around in the region. We keep hearing stories and anecdotal evidence from divers in the area who say that they are seeing a really increase in sand deposition since the reef started to be built. Both some people say that it's increased on the inside portion of the reef, and some people say they see large sand deposits outside the reef. And I'm wondering if your scientists have observed that.
We monitor. Actually, Dan, we want to respond it.
Yeah, just very quickly on that. We've seen no indication of that in our percent cover data of sand, which our divers measure across the entire footprint of the reef, the 373 acres. There was, after the phase 1 reef was put in, there was a little bit of sand burial on one of the modules up by the rocks off San Clemente, but that has remained that way for the last 20 years. But we've not seen any indication of sand burial or inundation on the rest of the 373 acres of the reef.
Okay, great. Thank you.
Bye-bye.
Where did Kat go? Hey, are there more questions? Okay, we have more questions coming up.
Question from Nancy Caruso.
I think you just said my name.
Nancy?
Yes.
Yes.
Okay,
You're on.
good. Hi. Thank you. Thank you so much for the presentation. It's always great to hear the updates. My name is Nancy Caruso, and I'm a marine biologist in Orange County. I'm the founder of Get Inspired, and I did kelp restoration in Orange County for 10 years. So I wanted to just let the person know who said that we lost 90%. We lost 90% in the late 90s, but we did restoration from 2002 to 2012. And so the kelp, luckily, is back. It's back even after the warm water blob and the El Nino. So we have not lost 90%. 90% is on the northern coast of California, just to clarify that. So I have a question for you. During the, and I'm still studying the Orange County kelp forest on an annual basis. So I just wondered, during the warm water blob and the El Nino events, the warm water events that took up 4 years of time along our coast, we saw a big proliferation of the Sargassum horneri, the invasive brown algae that's come into Southern California, unfortunately, over the last decade. And so I was wondering if you guys have seen that yet, either the Sargassum horneri, or we have a new invasive bryozoan that's showing up in Orange County, a water cypero. So I was wondering if you're seeing either of those invasives on the reef.
So our research team has seen those species, but not on the reef. not on the Wheeler North Reef.
Oh, that's good. Okay, well, let's keep our fingers crossed that it stays
Yeah.
on. That's fantastic news. Thank you.
Thanks, Nancy.
We have one more question, again from Chris Colba.
Thanks for calling on me. Just a quick cross comment on the sand deposition. That's a subject we've taken a hard look at over the past number of years, and the kelp maps that the U.S. Geologic Survey did going back to 1912, all the photographic surveys, and then our own studies and observation indicate quite clearly that along the Southern California bight, that when you have wider, heavier macrocystis kelp, you tend to have wider, healthier beachheads as a rule. That's not necessarily speaking to the substrate, that's speaking to the kelp. But I think common logic definitely presents that when you put structure that's less than a meter tall in 50 feet of water, a mile offshore, the chances of that in any way affecting the beachhead is just about zero. That's the observation that we've made. Thank you.
Thanks for your comment, Chris.
Okay, no more questions.
Oh, yeah, go ahead.
What about the field we're talking about in our neighborhood or even our city or the county, whatever? I get a question now and then about kelp, and can kelp be a tool, so to speak, to use to stop erosion and to stop the power of a waves? Now, I've talked to lifeguards about this, I've talked to specialists about it, consultants, et cetera. And that's all I hear from them, is from a science perspective, no. Because one of the reasons this gentleman offered is that because kelp is so valuable, it was with the waves, and it's not going to block them. Could I have some responses from your department here on that question? So I may have a better answer to give to these people. They're looking for kelp. If you put a jetty in, there's talk about putting some jetties in or some reefs that it's implementing to help with the erosion problem that we're having with sand loss and off our beaches, et cetera. And so one of the elements that people are saying is, oh, if we have a lot of kelp on those, that will slow down the waves and break them, so they won't come up as far as sea level rise, et cetera, et cetera.
So
repeat the question.
So the question was, does kelp have the capacity to basically attenuate waves and make it so that there's less coastal erosion? And is there an incentive to having kelp as a method for like shoreline armoring, basically, right?
That was great.
Well, there are a few things. I think your question is saying that the kelp may cause erosion to the beach, correct?
Prevent. Yeah, the kelp could prevent erosion.
Oh, but kelp prevent erosion. I think kelp generally has no positive or negative impacts on the beaches. The kelp does not affect the wave climate, okay, in any way, right? And of course, you can build a huge kelp reef, goes for kilometers from and that will have some effect. But for those kelp, which is similar to Wheeler North Reef or larger, twice time or three times Wheeler North Reef, they will not have impact on the beach, positive or negative, right?
I would just add to that, Hani mentioned that kelp's very malleable in the waves.
The compliant, yes, the fact is that.
What you see is when the waves are big enough, the waves aren't blocking the kelp, the kelp ends up on the beach, right? The waves take the kelp out, right? And so it's not like it's suppressing the waves go through the kelp.
It goes
That's
through it.
what Hani's big issue. Except for the very low frequency or
High frequency can impact it. You see,
Like
high
the
frequency like wind waves.
Waves can flatten that.
Right. That's why when you look for the kelp, you find the kelp calm as a kelp, right? Because it dump the 3 seconds or less frequency, which is caused by wind.
Yeah.
Right. But I think the statement is very clear. We don't have positive or negative impacts on the beaches.
Well,
Yes.
that's what I told, that was been my response to the questions when they were asking me that I didn't think kelp had that kind of effect.
So the one thing I was just gonna add to that is that there is a lot of like Ocean Conservancy, I'm on their website right now, and they have a very specific, they said Kelp Forest Act to reduce the force of tides and serves as a sort of fence to help retain near shore sand. So they're saying they're
No.
helping sand.
I got your question.
Those comments are made a lot, and to say that kelp
Sure,
reduces tides
sure.
was affecting the moon, I don't understand. Right?
It's saying reduce it, it says reduces the force of.
Correct,
storm driven.
correct. I will answer here then. Yes, kelp had impact on coastal tides. Coastal tides are perpendicular, to the shoreline, right? Are perpendicular to the shoreline, further away for an area where the wave active to move the sediment samples on the beaches. So yes, the kelp had effect on what we call coastal currents, which is further away from the surf zone, behind the surf zone, right? Which is the area active for the wave to change the beaches. Does that answer your question?
Yeah, I think so. You're saying if it's near shore.
It's different type of currents.
Yeah,
And the tide is a coastal currents further away, that's far away, right? And it's parallel to the shoreline. And the kelp can dump it actually. Dump it, and the dumping was quite a lot of an issue, right? Because it's not like the wave, right? So it acts like reducing the energy of the coastal currents. So the sand movement can caused by different type of current. It's called longshore current and induced by the angle between the wave and the bathymetry, right? So the angle bathymetry and the wave comes an angle, so producing transport to the beaches. So it's a different type of currents we talk about. Okay. Secondly, I wanted also, Wheeler North Reef is further away from the shoreline. It's an area where we call it after the closure tips, which is not really included in the sediment transport in the littoral cell, right? What away, right?
Yeah.
But I hope this subject ended now because we've been through this question several times, and I say, well, they are very useful and appreciable questions, right? I think they are good questions, and thank you for giving me the opportunity to respond.
Thanks for all the engagement. We're going to hold questions until the end so that we can finish the next talk. And then all the people that might be remote that have additional questions, we will get to those at the end of Rachel's talk. So Rachel.
Thanks, Kat. Okay, thanks everyone. Great questions. And so now I'm going to move on to talking about our plans for reduced monitoring of Wheeler North Reef. And so there are provisions in the SONG's coastal development permit to reduce monitoring to annual site inspections once Wheeler North Reef has successfully met its performance standard. And specifically, condition C of the permit states that after 10 years of monitoring that demonstrate that the artificial reef has successfully met its standard, the monitoring shall be reduced to annual site inspections, which serve to identify any non-compliance with the performance standards. Second, condition D of the permit states that monitoring may be reduced after the performance standards have been met each year for a 3-year period. And so reducing monitoring of Wheeler North Reef in accordance with the SONG's permit requires answers to 3 questions. And so first, what types of performance, first, what types of performance standards can be evaluated with annual site inspections? Second, what level of monitoring is sufficient for annual site inspections to identify any non-compliance with the performance standards? And third, when can monitoring be reduced to annual site inspections? And so over the course of this talk, we're going to walk through the answers to these 3 questions, beginning with the first one. And answering this first question requires an understanding of the 3 different types of performance standards, which Kat already introduced, but I'll remind you now. We have relative performance standards that require Wheeler North Reef to be similar to reference sites every year. We have absolute performance standards that are measured at Wheeler North Reef only that must be met every year. And then we also have absolute performance standards that are measured at Wheeler North Reef only that accumulate mitigation credit over time until a required value is met. And so the SONGS permit states that the monitoring program will be scaled down to annual site inspections when the project is successful, and success is determined as when performance standards have been met each year for a 3-year period. And that detail is important because success is not measured annually for all of the performance standards. And so whereas the success of types 1 and 2 is evaluated every year, type 3 performance standards accumulate mitigation credit over time, and they're deemed successful only after they have accumulated enough credit to meet the mitigation requirement. So therefore, annual site inspections are only applicable to standards 1 and 2, but not to 3. And so determining the best way to reduce effort for annual site inspections depends on the sampling method that's used to evaluate the different standards. And so we use 2 different sampling methods for our performance standards. First, we have transect surveys that are used to evaluate these annual absolute standards for hard substrate and undesirable species, and then also relative standards 1 through 8. And then second, the data obtained from fish collections are used to evaluate performance standards 9 through 11. And so for these 2 different types of performance standards, we need to determine what level of monitoring is sufficient for annual site inspections. And we're going to begin with those performance standards that are sampled with transect surveys. And understanding the rationale and approach for our current monitoring program provides some really helpful context for understanding our approach to the annual site inspections. And so the approach that we use for full monitoring is based on a desire to detect a 20% difference between the mean values for the lowest and the second lowest performing reefs with relatively high confidence. And for this, we use a sample size of 82 transects, and we use probability values to detect differences among the reefs. In contrast, for annual site inspections, our approach for this was really based on a goal of substantially reducing the monitoring, substantially reducing the sample size, but also maintaining capacity to identify non-compliance with the performance standards. And that comes with the understanding that we will have less assurance of correctly identifying non-compliance than that obtained from full monitoring. And so with this approach, we're looking at 15 transects per reef, and instead we're using ranked values to simply detect differences among the reefs. And so now looking at those standards, answering the same question for those standards that are sampled by collecting fish. Again, we have 3 performance standards that require fish collections, and they require different numbers of fish species and individual numbers of fish. And so for the first performance standard of fish production, in our current method, we measure the growth and gonadal production of 5 indicator species, and we collect 75 to 100 individuals per species per reef. And in our proposed annual site inspection, we're no longer going to use fish collections for this performance standard, and instead we will use transect data on fish biomass density of 5 indicator species as a proxy for fish production. For fish reproductive rates, we currently measure annual fecundity of 4 indicator species and collect 75 to 100 individuals per species per reef. And in our proposed annual site inspections, we'll measure annual fecundity of 2 indicator species and collect 40 to 50 individuals per species per reef. And lastly, for fish food chain support, we currently measure gut fullness of 2 indicator species and collect 75 to 100 individuals per species per reef. And in the proposed annual site inspections, we will measure gut fullness of 2 indicator species and collect 40 to 50 individuals per species per reef. And so using the existing monitoring data, we wanted to compare the performance of each reef using this full monitoring method versus the performance that would have resulted from the method proposed for annual site inspections. And so shown in this table is for each year, the number of relative performance standards that were met out of 11 for the current method on each of the reefs. And so you can see that Wheeler North Reef typically meets more relative performance standards than San Mateo, but fewer than Barn. And so this annual site inspection column shows the number of relative standards that were met when we retroactively subset the data to include only those transects and the fish sample sizes that are planned for annual site inspections. And so as you can see, the number of relative standards met each year by each reef was similar for these 2 methods. And so that outcome suggests that the method proposed for annual site inspections should be sufficient for identifying non-compliance of the performance standards. And so we also wanted to know the extent to which reducing monitoring to annual site inspections might affect Wheeler North Reef's ability to earn mitigation credit. And so to do this, we assessed Wheeler North Reef's ability to meet the annual mitigation requirement for both these relative standards and the 2 annual absolute standards for both the current method and for the method proposed for annual site inspections. And so a yes in this table on the right indicates that Wheeler North Reef met the annual mitigation requirement for both of those types of performance standards. And so the results show that Wheeler North Reef would have met the annual mitigation requirement for the relative and absolute performance standards in every year with both of these methods. And so that suggests that reducing monitoring to annual site inspections likely will not significantly affect Wheeler North's ability to earn mitigation credit. And so to answer this last question of when can monitoring be reduced to annual site inspections, the permit states that after 10 years of monitoring and 3 consecutive years of Wheeler North Reef successfully meeting the performance standards, that's what is needed before monitoring can be reduced to annual site inspections. And so full monitoring using the 4-year running average to evaluate the performance standards began in 2012. So that means that we have already met this 10-year requirement. And then 3 successive years in meeting the performance standards begins in 2021 following the construction of phase 3. So that means that the soonest that annual site inspections can begin is in 2024. And so for annual site inspections to begin in 2024, Wheeler North Reef must pass the relative standards and the absolute standards for hard substrate and undesirable and invasive species in 2023. And we're hopeful that this will be the case. As you can see, it's passed these performance standards every year since 2012, but stay tuned for next year. 2023 will be an important year. And so here we're going to provide a summary of the proposed annual site inspections and then the associated reductions in sampling effort for each type of performance standard. And so for those relative standards that are sampled with transects, we will be reducing from our current sampling of 246 transects to 45 transects, which represents an 82% reduction in sampling effort. For those relative standards that are sampled with fish collections, we will be reducing from 5 species with 100 fish collected per species per reef to 3 species with 50 fish per species per reef, which represents a 70% reduction in sampling effort. And then for those absolute annual standards that are measured on Wheeler North Reef only, we will be reducing from 82 transects to 15 transects, which again represents an 82% reduction in sampling effort. And so now to return to those types of performance standards that are amenable to assessment with annual site inspections. As we discussed previously, annual site inspections are not applicable to this 3rd type of performance standard that accumulates mitigation credit over time until the required value is met. However, in implementing annual site inspections for the first 2 types of standards, as we just discussed, that may provide opportunities for reducing sampling effort for this 3rd type of standard. And so we then explored whether the monitoring effort for absolute performance standards that accumulate credit over time may also be reduced given our approach for annual site inspections. And so as Kat mentioned in her talk, these cumulative standards include fish standing stock and giant kelp area. And in our current sampling approach, data collected from the 82 transects at Wheeler North Reef to evaluate the relative standards and the annual absolute standards are also used to evaluate these cumulative standards. And so given the fact that during annual site inspections, we're expecting to reduce from 82 transects to 15 transects, we wanted to ask whether we need all 82 transects to evaluate fish standing stock and giant kelp area when 67 of them will no longer be sampled in annual site inspections. And so this is a map with the locations of the 82 transects that are used to evaluate the relative standards and the absolute annual performance standards. And so you can see the locations of the transects with the diagonal black lines. And so you can see that we have 12 of these transects on phase 1, which is shown in pink. And we have 70 transects that are arranged in 35 pairs, which are on the phase 2 primary polygons, which are shown in green. And then we also measure fish standing stock and kelp area on 10 transects arranged in 5 pairs on the phase 2 contingency polygons, which are in yellow. And so evaluating the 2 cumulative performance standards requires a spatially distributed sampling scheme that accurately estimates the area of kelp and standing stock of fish across all 373 acres of Wheeler North Reef, including phase 3, which is shown here in white. And so that sampling effort involves 151 transects, which are spread across the phases as follows. So we again have 12 transects on phase 1. We have 80 transects that are arranged in 40 pairs on phase 2. And we have 59 transects on phase 3. And so a proposed method for reducing the sampling effort, but still maintaining this broad spatial coverage, is to eliminate one of the transects in each of the 40 pairs on phase 2. And so this would reduce the number of transects sampled for fish standing stock and giant kelp area from 151 transects to 111 transects. And so if we wanted to use our existing data to compare the kelp area and fish standing stock using the current versus the reduced methods, here are time series of adult kelp on Wheeler North Reef on the left and fish standing stock on the right for both the current monitoring effort, which is shown by the black circles, and relative to the reduced monitoring effort, which is shown in the white open circles. And so these graphs indicate that the proposed reduction in sampling effort from 151 transects to 111 transects will likely have little effect on the estimates of kelp area and fish standing stock. And so just to come back to the bigger picture, I guess reduced monitoring for for all of these will begin in 2024, provided that the results of full monitoring in 2023 show that Wheeler North Reef has met the annual requirements for both the relative standards and the annual absolute performance standards. And again, it has consistently met these standards for the past 10 years. So we're excited to see what our 2023 data brings, and stay tuned for that. And so at this point, we'd be happy to take any questions and either about the reduced monitoring or other broader questions about the rest of the performance talk.
We have a question on one from Susie Whitelock.
Hello, I'm withdrawing my question. Thank you.
Any other questions?
I don't have anything on that.
Yes.
I don't have a question, but I do have a comment. As somebody who's been involved with these issues for decades,
Yep.
I really appreciate the time to come down and not only do virtual Zoom, but also meet with us. I've come to these before when they were data point, other community centers, and it's really great to have the interaction from all of your staff members as well as the commissioners and the people. And I remember going to one where a whole side was fishermen.
Oh, wow.
I remember that. That was a very active meeting. That took not 5 hours. But you stood us all out and on that very populated meeting, and it just is a show of your own commitment to keeping our oceans clean and our beaches cleaner. Thank you.
Just a comment, appreciating all the work that we all do.
In person.
And being in person, that's right.
I just have a last time. Also data sharing question.
Yeah.
So the city of San Clemente, we've had a lot of talk about beach erosion and needing sand for our beaches. And one of our wants for the city is offshore surveys of potential sand deposits. So in all the work that you have done, is there anything that might be able to help us identify where there might be some sand deposits on the coast?
So the question is, do we have data that could help the city of San Clemente identify offshore sand deposits?
Yes.
What we do have data on is every year we go out and we estimate in our permanent stations off the Wheeler North Reef, which is the one reef off San Clemente. Those 151 stations, we estimate what the percent cover of sand is. We don't estimate the depth of the sand, but we do estimate the percent cover. Once every 5 years, sonar work is done to estimate the footprint area of the exposed hard substrate. And so the extent to which those data might be useful for you in terms of seeing how that changes over time, we're happy to facilitate the transfer, or if you need those data worked up somehow, we could probably do that for the city as well.
But it doesn't extend off the footprint of Okay.
We do not collect data off the footprint. What there are, and Hani can speak to this probably, there was a lot of siting and design work before there was put in. And so there was a lot of sonar work. There was some sub-bottom profile work done to measure the depth of the sand. So there's some historical data on that. If one was to want to see how that historical data has, or how things are now, if there were new surveys that were done, there would be historical data to compare those new surveys to. And Hani is the person that led all that work. And
I think there are some studies, the Corps of Engineers have recently done a study because they are planning to put about 4,000 cubic yards of sand on St. Clement Beach.
Yeah.
They done report in 2016. I'm sure if you look for this report, you find some important information for you, but at the same time, I mean, we have to get you when you want, right? But providing most information we have, right? But I think the first thing is to really look what studies has been carried out. Also, the Corps of Engineers in the past, in 1991, Corps of Engineers study in 1999. At least some of the questions you raised, information which you needed today. I think that would be good thing. And I don't know, I can give them or some reference to you for later. We can find some information about that.
Okay, thank you.
And look for this report, they have a lot of information.
we're easy to get a hold of. We're happy to certainly through our website. If you want, we can write that down for you. If you're on our email list, you can just ping us. We'll respond. And if we need Hani's help, we certainly know how to get a hold of Hani to enlist his help.
Yeah, okay. I've been kind of thinking, should I pipe in on this topic or? But the sand, the pocket sandy beaches are a big problem in Southern California. So San Clemente's not the only one, and the Coastal Commission is, inundated with issues of people needing sand. And I always say sand is one of the the second most limited resource on our planet behind water. It's, and we've dammed our rivers, so there's a lot of sand behind dams. And we've armored our coast, which doesn't allow the sea, the cliffs to erode. But there's a lot of sand offshore, but it's not just sand, it's also a community. So we are up against, the fact that there are resources, in fauna, epifauna that live in that sand. So it's a complicated issue. And, people are talking about barging sand down from British Columbia, bringing, a lot of opportunistic sand projects. So, but I think it's 1 million cubic yards are planned by the Army Corps of Engineers soon for San Clemente. So,
but that's coming from offshore, outside the ocean side.
Right.
So I think the idea is that if there's sand closer to, it would be nice to know what our offshore
right,
resources are, and that wouldn't really have, impacts.
Yeah, and the question is, do you dig deep down or do you spread it out?
Right.
A lot of different questions. But it's a problem and a big, topic for conversation, and we need sand.
Yeah.
No one wants to manage retreats.
Okay, are we good? Well,
Stay if there's any.
no more questions? All right, well, thank you all. Yeah.